This lecture will explain the various rules of commutativity. So commutativity is a property. In math, for instance, addition is commutative. So 7 plus 5 is the same thing as 5 plus 7. The order doesn't matter. Likewise, multiplication, 7 times 7, that's a bad example because it's going to look the same. How about 7 times 5? Let's not get creative. Is the same thing as 5 times 7. The order doesn't matter. However, some things, like 7 minus 5, so subtraction, that is not equal to 5 minus 7. They have different solutions. Okay, so we have, so some of our connectors work the same way in logic. The order of the different formulas in a formula that's commutative doesn't matter. For example, in a conjunction. So if you have the formula P and Q, that is equivalent to the formula Q and P. The order of the conjuncts doesn't matter. This is a two-way rule. We can go from P and Q to Q and P, or vice versa. We can go from Q and P to P and Q. And that makes sense. Now we're going to use the abbreviation COMM to stand for commutativity. And your book has two versions. Well, it has two versions in Chapter 6, and there's another version I'm going to talk about that's in Chapter 7. And so they write COMM and to indicate that they're using the rule of commutativity for conjunction. I don't need that part. Just com is fine. I'll be able to tell just by looking at the formula, by looking at the statement that you're applying it to, which version of the rule you're using. And I can say, yes, that's a correct thing to do. So you can just write com. Likewise, or is commutative. So P or Q is equivalent to Q or P. So if we have P or Q, we can switch that around whenever we like and get Q or P, or we can switch it back, vice versa. Okay, finally, in Chapter 7, your text explains that the biconditional is also commutative. So we'll also have a rule of commutativity for the biconditional. And then that just likewise says that P if and only if Q is equivalent to Q if and only if P. So commutativity is a pretty simple rule. It doesn't have a lot of utility, but sometimes it does in order to get other things set up for sort of the right form. That's usually where it comes into play, but you might find other uses for it. A couple of the proofs that we have done in, like, say, Chapter 4, there was at least one proof where having the rule of commutativity would have let you not have to take an and statement all apart and then put it back together again in the other order. So it can save you a few lines, but it's not a hugely useful rule, but it's a pretty simple one.